Hello and welcome to the fabulous world of welding. Alright guys, we're working on chapter 21, MIG application. So what we're going to talk about is what we have to do with certain things and how to make things work well. Okay, so the first thing we're going to talk about is edge preparation. Okay, so it says a butt joint with no edge preparation with 1/16 to 3/32 root opening can be used for carbon steel 3/16 to 1/4 inch. What they're saying is anything over 1/4 of an inch requires a bevel. Now, why do we say that? So if we look at here, I want you to think about, well, if I have a thinner piece of material, I'm more likely to be able to get into this joint. But here's the thing. If it's bigger than an 1/8 inch or bigger than 1/4 of an inch, I'm going to have a really hard time getting down to the bottom to have complete penetration into my root. So anything over 1/4 of an inch needs some sort of edge preparation. That means it can be a bevel. That means what they say is anything over greater than an inch would also need a U-groove. But we can also put a regular V-groove on there or anything else to make sure that there is some sort of edge preparation. Okay, so it's whether it's a 16th or a 3/32, that's fine. But if it's greater than 1 inch, we're going to use a U-groove. And if it's greater than 1/4 inch, it needs like a V-groove. Okay, makes sense, guys? Hope so. All right, so welding parameters like electrode diameter, our wire feed speed, aka amperage or current, voltage, and shielding gas. Well, they're known to be on rule what? Rule number 3. 90% of what we do is based upon thickness of material. So let's look at our information that we have here. Oh, come back here. All right, well, I'm going to behave. So when we look at this, we need to look at the chart that we have. This one's also in your book, okay? So this gives us thickness of material, guys. 0.025, 0.031, 0.037, 0.050. Oh, here's an 1/8 of an inch, 0.125, or 1/4 of an inch, 0.250. It's going to tell us the average electrode diameter that we should be using. Well, currently in class, we're using 0.035, so we can see all of the ways that 0.035 can be used. And then we're going to start to look at the current and the wire feed speeds, okay? So remember that short circuit, what we're doing in class, is inherently cold. So it's not going to get as hot as maybe we think it should be. But this is going to give you a good basis to what we need to be doing, okay? So it's telling us current, 140 to 160 amps, 19 to 22 voltage, 240 to 290 on our wire feed speed. Okay, travel speed, this is kind of negotiable because the average person welds between 6 and 8 inches per minute. So sometimes when we see a very, very quick travel speed, it means, hey, we need to be moving, otherwise we're going to burn through this stuff. Okay. All right, and remember, this isn't all, set in stone. Okay, this gives you a good jumping off point if I'm not certain. Okay, now we're talking about short circuit here. Now, the other one, this one is for aluminum. Same thing though, rule number 3 applies here. Rule number 3 says 90% of what I do is based upon thickness of material. Okay. Now they also bring something into here, which is edge preparation. Okay, so look at how thick this material is. It's not very thick. Okay. And it's saying if we have any of these, we need to have a lap T or a tight butt, a lap T or a tight butt, lap T or tight butt. And then look at the electrode diameter. It's 0.030. Okay. We also know that aluminum requires 100% argon. DC/EP current, 40, 50, 60, and 90 amps. Voltage, 15. But look at our feed speed. Okay, so remember, we know that feed speed and current are relational, right? So we see that we have to really bump it up a whole bunch for it to work well. Now, the reason why we're going to bump it up is because we need to go very quickly because aluminum is very liquidy, And when we run it, you're going to have to run quickly, okay? It takes enough to melt it, and we need to just keep on moving with it, okay? And that's why we also don't need a larger electrode diameter, because of how it spreads out and how liquidy it becomes. But here it is, aluminum spray transfer, okay? Spray transfer is a lot harder. Oops, come back. And we can go on thicker materials. Usually the thicker materials in aluminum means 1/4 inch and above. Okay, now we need to look at our edge preparation here. Single V groove with a 60-degree groove angle. That means a 30-degree on each side. We can have a sharp root face, and we're going to use a backing bar or no backing bar. Okay, it's going to tell us we need a lot bigger electrode, a 3/64, a 1/16. Okay, we're going to have to bump up our flow, definitely bump up our current. We're going to need a whole bunch more current. And then we're also going to have to do a bunch of other things with our voltage. Okay, so we're seeing that current goes up, voltage comes up, argon goes up. The reason this happens is we need it to be hot in order for the spray transfer to spray. Okay, they prefer this when we do aluminum into spray transfer. Makes it a whole lot easier. It's hot, it gets into these sections, and you're not having to overwork your material. Okay. All right, let's keep on moving, guys. All right, so on stainless steel, a 1/4 inch or more, you should do a back and forth and a side to side. Okay. So when we're talking about thick stainless, it's kind of like that. And for thinner, okay. All right, so short circuit can also be used on stainless steel, thin. And we can also use it in overhead and vertical, okay? We're going to use short circuit in out of position welding because it's generally cooler, okay? We can also use a smaller diameter electrode, okay? Up to a 1/4 inch, we're using 030, okay? And we have to remember this is quite thin, okay? And if we look at it, our amperage is only 125 amps with 17 volts, and our feed speed is 280, okay? So we're doing rather well with short circuit, okay? Remember, this gives us an idea of where we need to be at, okay? All right, so when we look at spray transfer for stainless, it changes the whole deal. Okay, here. Now, it's saying that our edge preparation, square groove with the backing, single V butt. Okay, so we're looking at, we're over a 1/4 inch. We require some sort of edge preparation. And our electrode diameters grow considerably. We're also going to need a lot more gas flow. And we're also going to inject a little bit of oxygen to make it just a little bit hotter. Okay. Now our voltage gets a lot hotter because what? Spray transfer requires us to make it hot so that instead of it being a short circuit, the arc melts the wire before it hits the material. Okay, so our feed speed, 110, 150, this is 1/4 inch. This is getting pretty hot. Okay, and we're at 24 volts, which means the voltage will help our contour. The voltage will also help us get better penetration. Okay, so let's look at another one. Copper. Who knew you could weld copper? Well, let me show you something, guys. So remember, rule number 3 runs here. This is 90% of what I do. Thickness of material dictates everything. Okay, now copper. Usually we're going to only use deoxidized coppers because, you know, some of the other stuff can give us a hard time, but we really need to pay attention to how much heat we're actually having to put into this. Okay, copper dissipates heat very, very quickly. Okay, so at an 1/8 inch, 1/16 inch diameter, our current is 310. Our volts at 27 and our feed speed at 200. Okay, anything over, let's say 3/8 of an inch needs to be preheated to a minimum of 400 degrees because otherwise it will dissipate the heat so quickly you couldn't get it to stay. Okay. Now, quite honestly, I'm not even sure if the machines that we have get this hot. Okay. This means this thing has to be flying, and we have to put a bunch of heat into this. Look at this. Our welding speeds 30, 20, and 20. And if we look at the little note, it says in inches per minute. I have to do 30 inches per minute in order to get this into this 1/8 inch. That's a ton of heat that has to go into this. Okay. Now, remember, welding parameters are set based on the thickness of material. Argon is the preferred shielding gas for GMAW on aluminum up to 1 inch thick because it provides better metal transfer and arc stability with less spatter. Okay. When using GMAW on stainless, you need to also make sure that you have correct ventilation. There's this stuff called the hexachromium stuff that you can never pronounce, and if it gets into your lungs, it's really, really bad. Okay, so when we're welding copper that 1/8 inch thick or less, we would use a steel backing bar. Okay, if we are welding on thin stainless steel, we can use a copper backing bar. Okay, of course, preheating copper at 400 degrees is advisable on anything over 3/8 of an inch. All right, guys, as usual, if you have any questions, concerns, comments, or you're just not sure about something, let me know. Regardless of what class you're in, I'm sure I can help. Take care.